1984, a pair of paleontologists named David Rohr and Jack Sapolsky were studying the history of mass extinctions on Earth over the past 250 million years when they noticed something extraordinary. Of the dozens of mass extinction events they studied, all seemed to fall almost exactly into a fairly regular pattern, occurring every 26 to 27 million years. The breadth of such a timescale suggested to scientists that the possible cause for these extinctions stemmed from an astronomical source. Bolstering this hypothesis was the fact that at the time this was noted, two of the extinction events in question, the one at the end of the Cretaceous that had wiped out the dinosaurs, and another that marked the end of the Eocene, were almost certain to have been caused by impacts from celestial objects, as evidenced by telltale layers of iridium and shock quartz at the corresponding points in the geological strata. It didn't take long for astronomers to come up with a theory that every single one of the 12 events studied could have been caused by a similar impact by a comet or asteroid, and they began trying to come up with a mechanism by which this could have occurred. That same year, two teams of astronomers published papers in the journal Nature that separately made the case that the Sun might possess an unseen companion star dubbed Nemesis or the Death Star, whose long elliptical orbit could hypothetically dislodge comets from the Oort cloud, an enormous field of comets and other debris ringing the solar system outside the orbit of Pluto, and send them hurtling towards the Earth at regular 27 million year intervals. These proposed bombardments would last anywhere from 100,000 to 2 million years, completely upending the delicate balance of the planet's ecosystem and causing countless species to die off. Other theories behind mass extinctions. Of the 5 worst mass extinctions evident from the fossil record, only one has been definitely linked to an astronomical event: the cataclysmic Chicxulub asteroid strike near the Yucatan Peninsula that marked the end of the Cretaceous period around 66 million years ago and ushered in the Paleogene. Of the 4 other events, various other theories have been put forth as to probable sources of the upheavals. The extinction at the end of the Triassic, more than 200 million years ago, for example, could have possibly been caused by increased volcanic activity stemming from the rifting of the Pangaea supercontinent, which would have spewed masses of carbon dioxide into the atmosphere, causing extreme climate change and a drastic rise in sea levels. On the other hand, some experts maintain that just as in the Cretaceous ending impact event, a comet or asteroid smashing into the Earth might have wiped out a large percentage of species in one foul swoop, and subsequently altered the climate to a point where many other species died out slowly over the ensuing eons. The possibility that the other 3 major events were caused by a similar impact, though, is not quite so clear-cut. The end of the Ordovician period 444 million years ago, in which approximately 86% of species vanished from the fossil record, is thought to have been caused by a short but unusually severe ice age brought about by the exposed silicate rock from the recently uplifted Appalachian Mountains, drawing carbon dioxide out of the atmosphere. And the end Permian extinction, otherwise known as the Great Dying, in which an unbelievable 96% of species was wiped out, was likely triggered by a massive volcanic eruption near Siberia, which increased global temperatures and acidified the oceans. Likewise, the extinction occurring 375 million years ago at the end of the Devonian is generally blamed on the newly evolved land plants releasing nutrients into the oceans, which may have caused devastating algal blooms to form, wiping out many long-existing sea creatures such as the trilobites. That said, it's certainly within the realm of possibility that cosmic impacts may have been a major or supplemental factor in all such mass extinction events, and the evidence supporting this theory may still be waiting to be discovered. What is Nemesis, and why haven't we found it? The exact nature of the Sun's companion star Nemesis, and why it has never been spotted, have long been the subject of debate. While some astronomers like Richard Muller of the University of California at Berkeley posit that Nemesis could be a red dwarf star approximately 1.5 light-years from and a third of the size of the Sun, somewhere in the vicinity of the constellation Hydra. Others have conjectured that it could be a brown or white dwarf, a black hole, or an otherwise low-mass star that would be far too dim to detect easily. Muller noted that even a star with a magnitude between 8 and 12 would not be bright enough to show up in parallax surveys. The suggestion of Nemesis as a brown dwarf star seems only not from the relative brightness, but also from pure statistics. Brown dwarfs were once thought to be the most plentiful type of stars in our cosmic neighborhood. While more recent surveys have adjusted the commonality of this type of body, brown dwarf stars are now thought to comprise about a 1:6 ratio with other types of stars, as opposed to the 1:1 ratio suggested by earlier observations. They are still ubiquitous enough to be a decent candidate for Nemesis, and potentially dim enough to have avoided being seen. At the time of recording, over 1,800 brown dwarf stars have been observed in relatively close proximity. At the time the Nemesis story was put forward, it was thought that the majority of solar-type stars were part of binary systems, so the idea that the Sun would also have a companion, or being one that we had yet to discover, was not at all far-fetched, though, if Nemesis exists, it's the most distant star from its companion of any so far observed. A 2017 study demonstrated that indeed almost all Sun-like-type stars were originally formed as binaries, but could conceivably become separated from their companion stars as time went on. The authors of this study, Sarah Sadavoy and Stephen Stahler, therefore put forward the idea that Nemesis very well may have existed at one time, but broke free from the Sun billions of years ago, as its orbit would have been far too elliptical to have been maintained, and would have ensured that the star would have eventually have drifted away from its original system. However, later studies have tended to support the idea that the majority of Sun-type stars are single rather than binary, though whether these stars formed singly or later lost their companion stars remains an open question. The orbit of Sedna and the theoretical planet 9. Another point in favor of the continuing existence and proximity of Nemesis is the strange elliptical orbit of the dwarf planet Sedna, which, during its 11,400-year circuit, remains in an unusual limbo where it never gets close enough to the Sun to be affected by its gravity, but also never strays far enough away to be affected by the gravity of other objects. Some scientists have speculated that a companion star like Nemesis could explain the odd positioning of the dwarf planet, and it could theoretically keep it from entering the Sun's sphere of influence. Interestingly, the unusual movement of Sedna and other trans-Neptunian objects has led some astronomers to suggest not the presence of a yet as unknown star, but rather that of an enormous planet lurking around the outer edges of the solar system, throwing all the objects of the trans-Neptunian objects out of whack. These particular objects all have orbits tilted in a similar fashion, and all tend to cluster when at their nearest approach to the Sun, suggesting that some so far undiscovered body is affecting their motion. Though some experts attribute their irregular orbits to a group of smaller objects rather than just a single massive one, a paper published in January of 2019 in the Astronomical Journal estimates that the probability of this unknown planet not existing is approximately 1 in 500. The idea that there is a large, undiscovered planet beyond the orbit of Neptune is nothing new. It was first suggested in the mid-19th century, not long after the discovery of Neptune itself. Back then, the hypothetical planet was dubbed Planet X, though astronomers since the demotion of Pluto are more likely to call it Planet 9. Planet 9, if it exists, is believed to be 5 to 10 times more massive than Earth, an icy body a bit similar to Neptune, that may have once been at the core of a much larger planet, which was thrown out of its orbit by Jupiter when the solar system was first being formed. Alternatively, Planet 9 could have been a rogue planet, or one pulled into its present orbit by a star. On its current hypothetical course, it would take between 10,000 and 20,000 years to make one full orbit around the Sun. At its farthest point from the center of the solar system, it would be around 400 times the distance from the Sun to the Earth, or more than 37 billion miles away. Just as in the case of Nemesis, the presence of a speculative Planet 9 could account for comets and other bodies being knocked out of the Kuiper Belt and sent towards the interior of the solar system, where they would then make contact with Earth, causing mass extinctions. were comet impacts really responsible? On the other hand, some astronomers doubt that an astronomical body is responsible for the periodic extinction events at all. A 2010 study by Adrian Millot and Richard Bambach, for example, argues that the 27 million year interval is far too precisely calibrated to have been caused by comet impacts engendered by some notional object. Though their own survey of the fossil record has confirmed that the 27 million year cycle is accurate and extends twice as far back into deep time than previously thought. They state that a companion star to the Sun with an object such as that hypothesized for Nemesis would not be reliable enough to cause effects on such a regular basis. Other stars and objects, they further write, would have pulled Nemesis this way, and thus over time, its orbit would have become irregular and would not be able to account for the clock-like work extinction events of the past 500 million years. Conversely, a 2011 paper by Corinne Baylor-Jones put forth the theory that the evidence for the regularity of mass extinctions was simply a statistical anomaly, arguing that the pattern of craters seen on the Moon and other bodies did not support the idea of an intermittent comet bombardment. But if indeed some outer solar system objects are being displaced and tossed into the orbit of the inner planets, some other researchers surmise that the existence of Nemesis or Planet 9 is not necessary to account for the irregular orbits of such objects, as the gravitational pull from a passing star would likely to be sufficient to cause the observed effects. An analysis of positively dated impact craters on Earth by Richard Muller and Walter Alvarez, however, seemed to demonstrate that at least the last three of the major extinction events on the planet were heralded by groupings of craters, suggesting that several impacts took place in a relatively short time period, which would seem to add credence to the theory that an astronomical object of some type was affecting the movement of comets throughout the inner solar system. As of 2019, neither Nemesis nor Planet 9 has been found, despite repeated sky surveys with ever more powerful telescopes. Many astronomers state that if Nemesis is out there somewhere, it's likely it would have been detected by now, particularly by infrared observations. However, the existence of either cannot be ruled out, as their characteristics and locations may be making them difficult to detect.
Matiki doon sa sarayan.
hoy se supone que a las 12 de la noche, que hoy, 12 de la noche.
washed up on the beach right in front of the hotel. It's an old cross from somewhere. Got all kinds of barnacles on it. No telling how long it's been in the water.
tipped over in the wind. Frozen solid. He was in the middle of a fight with a fox. Froze solid. He's all wounded and shit. God, that's cool.
What does it sound? Sounds like a scary movie.
این بیچاره وای اینا رو وای وای خدای بزرگ خدای بزرگ کمکشون کن این بیچاره
یا قربان
برای مردم نمیرم اینا رو این وسط دیوانه
فرض العباس یا ابوالفرز العباس Maybe we could try something the next song. It's an old song called Said and Done.
That looks scary.
Oh, fuck you, John! Nope, nope, nope.
Where's he? Astagfirullahaladzim. Astagfirullahaladzim.
Woi, pada motor eh. Woi, pada motor eh. Allahu Akbar. Allahu Akbar. Allahu Akbar. Oi! Gunungnya amblek. Gunungnya amblek. Gunungnya amblek. Gunungnya amblek. Wonge, selamat Wonge. Woi, Wonge selamat. Hah? Woi. Wonge nanti Wonge. Woi. Wonge selamat kabeh. Back one and gone. Boy, he just beat this car. Hey, man, look at the side of this hole in this car. What is this car made of? Plastic? Wood? Paper? Man, look at that.
He got shot at.
Look at that.
Oh, man.
Man, this car, that's paper.
Yeah.
Huh?
I can hide my hand.
Man, God damn. Look at that. Boy, that was some hell on this poor car. This poor car caught hell.